Welcome to day 8 monitoring and visualization of our certified DevOps Engineer free live training program. This is our roadmap, and according to it, we have very successfully completed day 1 to day 7. And today we are going to start with day 8 monitoring and visualization. Everything you need to know about the monitoring to get started. So, today we are kicking things off with a part 1 monitoring essential fundamentals key concept. This is where we lay the foundation for understanding monitoring, why it is important, and how it helps keep system running smoothly. Now, this session is just beginning. In upcoming parts, we will explore Prometheus Grafana, its architecture, what its component, how it works. Then we will go and see step by step through installation of the Prometheus and Grafana, how they work together. Then we will deep dive into the containerized monitoring with Docker, where we will see how we monitor, how we can utilize this tool to monitor containers, as well as also how we set up Prometheus Grafana in Docker or container environment. Then we will scale observability in Kubernetes, and we will see how we configure Prometheus and Grafana in Kubernetes environment. And finally, master advanced techniques and best practices. But for now, let's focus on essentials. Before we go ahead, I would like to take a moment to personally acknowledge and thank each and every one of you for your love and support which we are receiving. This is really amazing. Thank you very much for that. These are our social media handles. We would love to stay in touch with you. If you would like to support us over there, please feel free. What are we covering in part 1? In part 1, we are diving into the fundamentals of monitoring, why it's essential, how it works, and the best practices to make it effective. First up, monitoring, the backbone of everything. We'll talk about what it is, why it matters, and how it helps keep our system running smoothly. Then we will break it down into a key components, what to focus on, and how each part plays a role in the bigger picture. Next, we will touch on visualization, turning raw data into clear, actionable insight. Of course, monitoring isn't just about watching, it's about reacting. That's where alerts and notifications come in. And when things do go wrong, incident management is the game plan. Finally, we will wrap up with observability, the next level of monitoring that gives us deeper insight into our system. Sounds good? Let's dive right in. The first thing first, what is monitoring? We could define this as it's like keeping an eye on something to track changes, to detect problem early. So you can act before small issues turn into bigger ones. Similarly, when you're driving a car, you constantly monitor the dashboard gauges, speed level, fuel levels, engine temperature to make sure everything is running smoothly. If the fuel is low or engine overheats, you immediately take action and take your car to workstation. I'm sorry, not workstation, workshop, right? To prevent a bigger problem down the road. Similarly, in IT, monitoring is the practice of continuously tracking system health and performance. It helps detect issues quickly and provides real-time visibility into a system status. Now that we have covered what monitoring is and why it matters, but how does it work? Let's break it down further. Monitoring isn't a one-size-fits-all approach. Monitoring in IT goes beyond just CPU and memory uses. It covers multiple specialized areas such as IT and system monitoring, application monitoring, security monitoring, automated and predictive monitoring, which is AI based, nowadays very popular. All these points which I have put it over here, the breakdown, it's completely based on my personal experience. Each plays a vital role ensuring different aspects of system health and performance. Now let's explore them one by one. Let's start with infrastructure monitoring. So infrastructure monitoring is all about tracking the core components of IT system to ensure stability, efficiency, and reliability. It includes monitoring like servers, network, storage systems, virtualization, or you track or you monitor your virtual machines, ESXi hosts, containers, Kubernetes, pods, everything, right? And overall hardware health as well. But the question is why it is important. So without proper infrastructure monitoring, IT system can suffer from performance issues, unexpected failures, and costly downtimes. By proactively managing these areas, organization prevent disruption, optimize efficiency, and ensure business continuity. So this is about infrastructure monitoring. Now let's move on to the network monitoring. Network monitoring focuses on ensuring fast, reliable, and secure connectivity across IT environments. It includes monitoring such as bandwidth uses, latency, connectivity, packet loss, traffic analysis, all these things. These are just few which I have mentioned over here. It could be many depending on organization to organization, what is your use case. But some of the important points I mentioned over here. And without network monitoring, business can experience low performance, connectivity failures, or even cyber attacks. By analyzing network health and traffic patterns, IT teams can prevent disruption and improve security. Okay, so network monitoring is also really, really important. Okay, so now we have talked about it. Next, let's dig into the database monitoring. Databases store and process critical business data, and monitoring them ensures performance, security, and availability. So now, so far, you already aware about how critical or how crucial the data is. Everything is data, right? We could have everything in place, but if we lost data, then we lost everything. And here in database monitoring, the key aspects includes like query performance, how query is performing when you execute any of the query, how long it takes to provide you the result. Similarly, the replication, if you have multiple or redundant database services, so what about their sync, right? Whether they are syncing in proper or not. Then availability, it's again the high issue, right? Indexing issue. If indexes are not good, you will not get the proper result. So indexing is also really, really important. Slow or unoptimized database can lead to application failures, frustrated user, and lost productivity. So monitoring helps organization maintain responsiveness, prevent downtime, and improve efficiency. So this is all about database monitoring. Now move on to log monitoring. Logs are the digital footprints of an IT system, recording every event, errors, and user actions. Log monitoring ensures visibility into system behavior and security compliance. Logs are very, very crucial, or I would say it is also equivalent to your data because it will give you the insight about your system, what is happening inside the overall environment based on the project, okay, or based on the application or based on the infrastructure, how crucial is it and what you want to monitor. So some key aspects of logs include the error logs, audit logs, and the event logs. Logs help IT teams diagnose problems, track security risk, and ensure compliances. Without monitoring, issues like unauthorized access or unnoticed error could go undetected, leading to serious consequences. Right? So it might be possible some hacker is trying to get into your system, okay, or into your application, and if you don't monitor the log, you cannot find what is happening inside the system. So this is about log monitoring. Finally, let's explore cloud monitoring. As business moves to the cloud, they need to monitor performance, cost, and security to avoid unexpected problems. Right? And key areas include cloud performance, cost management, resource utilization, and security compliances. So like there are cloud providers out there, they really, really good with the security compliances. They also share the shared responsibility model, right? They are also compliant, so you could deploy your application in the cloud as well. So cloud environments introduce new complexities, risk, and cost challenges. Without monitoring, businesses may face downtime, security breaches, or unexpected expenses. So it's very essential. And out of this, I would say if you're setting up monitoring of the cloud, enable the cost management monitoring. Okay. Of course, this is also an overall this is as well, depending on which team or to whom you are talking about the monitoring. For example, finance team wants to know how much you are spending, right? These are the some of the points which I mentioned over here. So finally, a final thought I would say each of these monitoring areas work together to keep IT systems reliable, secure, and efficient. Okay, by monitoring infrastructure, network, database, logs, cloud environment, business can prevent failures, optimize performance, and improve security before issues arise. So it's very important. I have tell you what you could monitor in case of IT or system monitoring. Okay, now that we have covered IT and system monitoring, move on to application monitoring next. Application monitoring focuses on ensuring that software, websites, and applications run efficiently, providing a smoother user experience and proactive issue detection. Let's break it down into a key categories. So first one is application performance monitoring, where you monitor a load times. Load times, it measures how quickly an application loads to prevent frustration of the user. Next, we have crash detection. So crash detection is also about whether your application is shut down unexpectedly, right? Or failure sometimes. So you maybe realize it already when you work with any of the application. So sometimes it get froze, then you have to forcefully terminate it, and then you get this application crashed or shut down unexpected. Would you like to report or something like that? So that is comes under this crash detection. Then we have response time. It tracks how fast the application react to user interaction. So this is application performance monitoring. We will go more deeper into it's not the only this three things. I'm just giving you the overview, and that's why this session is about and why it is important. The reason is very simple: slow or unreliable application can lead to poor user experience, reduce engagement, and financial losses. Monitoring ensures that application remains optimized and responsiveness. Okay. Next, user experience monitoring. So user experience, or in simple UX or UI UX, is also called, ensures the application is intuitive, error free, and accessible to all users, and which typically includes page load times. Previously, we were talking about the entire application load time, but here we are specifically about the page load time. Okay, which optimizes speed to ensure user doesn't experience delay at all. Next, we have error rates that tracks frequent issues like broken links or failed processes, like when you have something 404 or something like that. Okay, that is error rates. And we have responsiveness. It ensures application adapts well to different devices and screen sizes. And we have accessibility, which verifies usability for individual users. And it is important because well monitored UX enhances customer satisfaction, retention, and usability, and which also reduce the frustration, right? So that's why UI UX is really, really important. Next, we have real-time error tracking, detecting issues as they happen to allow instant troubleshooting. Okay, this includes like bug detection, identifying software glitches that impact functionality. Okay, exception handling, where logging and fixing errors before they disrupt overall operations. And debugging tool helps or provide insight to developers for fast issue resolution. Okay, detecting errors in real time helps prevent major failures, saving time and resources on fixes. So this is about real time error and tracking. Next, we have end user monitoring, which analyzes user behavior to improve functionality, navigation, and engagement, which typically include session tracking, observe user interaction, and engagement over the time with the application. We also have user flow analysis, where we maps navigate path to optimize user's journey. So for example, if you are searching for product A, so based on the history, okay, or other customers, maybe it could recommend you to do, would you also like to buy product B as well, because they go long. I just give you a simple example, when you buy it, realize it. Okay. Then we have click tracking, captures click pattern to ensure interface design and functionality. This is a summary what we have talked in application monitoring. So application monitoring is essential for performance, usability, and user satisfaction. By tracking these elements, business reduce downtime, improve experiences, and increase customer retention. Next up, security monitoring. Let's dive in. Security monitoring is critical for protecting system data and user from cyber attacks. Let's break it down into key categories. First one is threat detection and prevention, identifying and stopping cyber threats before they cause harm. In this, we have firewall and IDS, intrusion detection system monitoring, okay, where tracking intrusion attempts and blocking malicious activities. So this tool help us to track intrusion attempts and blocking malicious activity. But what happened when these tools is still not working? How would you know there is a something malicious activity or intrusion is being happened? So that's where, or that's why we have to monitor these devices as well. Next, data breaches, detecting unauthorized access and data leaks to prevent exposure. Okay, company really get very high fine when any data get breached. It is really important. Zero day threats, identifying unknown vulnerabilities before they are exploited. Malware analysis, phishing, and you just name it. There are so many things comes under these threat detection and prevention. So why this is important? Without strong threat detection, organization risk data loss, financial damages, and reputation harm from cyber attacks. Next, identity and access monitoring. It ensures secure access to system and preventing unauthorized activity, which includes user authentication, verifying user identity through password, biometrics, or multi-factor, or simply MFA. If you remember, when we set up a GitHub account, I told you whenever it's possible, enable two-factor authentication. Next come in this category, privilege escalation, tracking unauthorized attempts to log in, elevated system access. Then RBAC, which is simply role-based access control, okay, ensuring users have appropriate permissions based on their roles. Next, unauthorized access prevention, blocking unapproved login attempts and access requests. And why this is important? If access control is weak, Attacker can compromise accounts, steal data, or manipulate system settings, which leads to, again, very severe consequences for the company. Next, compliance and policy enforcement. Meeting legal and regulatory requirements while maintaining security best practices. So regulatory requirements like ensuring compliances with law like GDPR, HIPAA, and PCI DSS. Next, we have policy enforcements, implementing security protocols across the organization, and audit logs, tracking system activities to detect irregular behavior or policy violation. So again, it's the things which I'm telling you, it's all these are really important. And of course, based on my personal experience, so failure to comply with security regulation can lead to legal consequences, fines, and loss of customer trust. So that's why these regulatory requirements are over here. You may be heard in your company. Okay, if not, read about this. Okay? Compliance and policy enforcement is also a part of security monitoring. Next, license and usage monitoring, tracking software uses and ensuring compliances with licensing agreement. Right, it should not be like you are using any of the software which is not, and your company does not have license. Right, so, I mean, of course, it doesn't happen, right? But still, it also a kind of security comes under the security monitoring or falls under security monitoring domain, where we have software license compliances, which preventing violation of software uses policy, right? That's why whenever we install any of the software, they ask us to accept license terms and condition and uses policy. Okay. Next, we have usage tracking, monitoring how software tools are being utilized. Next, renewal management, which keeping track of license expiration dates to avoid disruption. And why this is important: improper software licensing can result in financial penalties, legal action, or operational disruption. So again, this is a summary about security monitoring. And security monitoring is essential for preventing cyber threats, ensuring compliances, and managing system access effectively. Without it, organizations are vulnerable to breaches, legal issues, and operational risks. So next we have automated predictive monitoring. Let's dive in. As I said, automated predictive monitoring, these are the future, or this is the future. And I've been using AI based monitoring, I think, more than 8 9 years. So it's not new for me. Yeah, nowadays it's AI become very popular, but it is with us since very long back. So automated and predictive monitoring is revolutionizing IT and system operations by using AI, machine learning, and automation to detect and prevent issues before they cause disruptions. Instead of reacting to problem, this approach enables proactive monitoring and optimization. Let's break it down to a key categories. First one is AI powered automated monitoring, using artificial intelligence and automation to continuously track system health without human intervention. So let's see first in this machine learning based alert or machine learning based monitoring. Okay, AI detects unusual patterns and automatically alerts the team or take actions on this. Next, we have autonomous system health checks. AI performs system diagnostics, ensuring optimal performance. Next, we have self-healing mechanisms. AI-driven automation fixes issues in real time without human intervention. And again, why this is important? So traditional monitoring relies on manual oversights, whereas AI-powered monitoring reacts instantly, reducing downtime and increasing efficiency. Next, we have predictive analytics and failure forecasting, leveraging historic data and trends analysis to anticipate future risks. So first in this, anomaly detection identifies unusual system behavior before it leads to a failure, which is based on the AI. Right? And we have predictive maintenance. AI predicts hardware degradation and schedules prevention error. Forecasting potential failures using data models to detect vulnerabilities and proactively address issues. So it's something like if you are doing something, AI immediately analyze and give you, okay, this is wrong or something like that. So, but it's completely without human intervention. So forecasting potential failures, anomaly detection, prediction maintenance, and why this is important. Instead of waiting for issues to happen, predictive analytics prevent outages, improve reliability, and reduce costly repairs. Next, in this domain, we have auto scaling and system optimization, automatically adjusting resources based on demand and system activities. Auto scaling solutions, first in this category, AI dynamically increase or decrease computing power based on workload needs. So maybe you already familiar about auto scaling in our cloud system, right? So that is different, and this is also different. Okay, it's completely based on the AI. So AI did its analysis, and based on that, it takes the decision. And next, we have improved system optimization using historic data. AI fine tunes configurations based on the past performance metrics. So these are the things, and why do you need it? So auto scaling ensures efficient resource allocation, preventing performance bottlenecks, slowdown, or unnecessary spending. So this is the summary about automated and predictive monitoring, which is shaping the future of IT monitoring by leveraging AI, automation, and predictive analytics. So that's about automated and predictive monitoring. Next, we have a quick summary of the key monitoring breakdowns. So I have just mentioned some of them. There are so many others, but today these are our focus. So each of these monitoring categories plays a crucial role in system reliability, security, and optimization. But monitoring is only effective if the teams can quickly understand system data and act on that. That's where visualization comes in, which transforms data into meaningful insight. Think of it like driving a car. You don't just want a long list of numbers about the fuel levels, speed, engine, health. You need a dashboard with gauges and warning lights to make quick decisions. Similarly, monitoring dashboards, graph, heat maps, and alerts provides IT team with real-time insights, helping them track performance trends, identify issues faster, and make proactive decisions. So these are the key visualization components. Whenever you have any visualization tool, you have one dashboard where you could see everything. You have graphs and charts, pie chart and bars, and we will see when we set up a Grafana, we will create our own dashboards. Visualization tools also provide us a log analysis views. We also have heat maps. When you have thousands of servers across the globe, then you cannot watch one server at a time, right? Or one system at a time. Instead, you like to see them in a heat map. So these are the some key components which belong to the monitoring. So if you see, I have taken this example from the Grafana official website itself. If you see over here, right, so we have this one graph, right, HTTP. Here you could see the request down connection, and this one is the total number of requests where we have graph about this. This is latency heat map. You can set up, right? So heat map actually looks like this, and you also have average percentile latencies. Okay, so depending on what you want to monitor, so this is how it's a dashboard example I have taken from Grafana website. It looks like we will create our own dashboard. So by leveraging this visual monitoring techniques, IT team can streamline operations, predict issues faster, and make data driven improvements. But what if problem occurs? That's where alerting comes in, and which is our next topic: alerts and notification. So monitoring isn't just about collecting and visualization or visualizing data. It's about taking action when something goes wrong. If a system failures happen in the middle of the night without alerts and notification, IT teams wouldn't know until user reports an issue or operations come to halt. That's why alert and notifications are critical in proactive monitoring. So alerting is the process of notifying teams when monitoring detects anomalies and threshold breaches. This is about alerting when, so you can notify team via email, via Teams chat, or any Slack channels, or whatever communication channels you have, even though the tools are available which automatically trigger a call, whoever responsible person or on-call person during that period. Or you can simply send them a ticket to work on. Okay. But simply detecting the issue isn't enough. Team must resolve incident efficiently, minimize impact, and prevent recurrence. This is where incident management comes in. That is our next thing. So incident management is a process of identifying, responding to, and resolving unexpected issues, right, that disrupt normal operations like system outage, security breaches, or application failures. It ensures problems are handled efficiently to minimize impact and restore services as quickly as possible. So like rest of the other parts in the monitoring, incident management also have some of the key steps. We have first incident detection, so identifying the issue through the monitoring alerts and user reports. So in that, we already set up a monitoring tool alerting, right, and the user reports are being generated. Out of those, we find, okay, is there any detection of the incident, not the detection. Once incident identified, then you have incident classification, okay, where you define the criticality or level of the severity of the incident, okay, whether it's a critical, high, medium, low, and prioritize the response. So incident management is different and response is different. We are focusing on incident management. Then we have response and investigation. Next one. So engaging the right team to diagnose and mitigate the problem. So first we detect the incident, then we classify the incident. Right? Accordingly, we inform a team or involve a team. Okay, those who are responsible, they can investigate and they can mitigate the problem. Next, we have resolution and recovery. After that, implementing fixes to restore normal operation. And once it is done, incident is completely done, then you have post incident analysis, which is usually called in postmortem. So where we review root cause, document findings, and improving process. So these are the some key steps which are followed when incident happen, okay, in order to manage an incident. So incident detection, classification, where you define the priority or severity, and response and investigation. Then you, once you have involved the proper team, then we provide a proper resolution and recovery. So once incident is closed, after that other teams involved, okay, like this, and they try to identify root cause, why and what happened. Okay, so this is about the incident management. So until now we have covered monitoring, visualization, alerts, notification, and incident management, all essential for keeping IT system running smoothly. But these methods mostly focus on reacting to issues. What if we could go beyond just detecting problems and instead understanding the deeper causes before they escalate? This is where observability comes in, and that is our next topic. So observability, or I would say the monitoring, tells us what is happening, okay, where observability tells us why is it's happening. So monitoring tells us what is happening, and observability let us know why it is happening. So observability goes beyond monitoring, helps diagnose the root cause of issue, okay. And similarly, there are some core pillars of observability. So observability relies on three key pillars to provide a complete picture of a system behavior. First one is metrics, okay, performance data, CPU, uses, latency, request, that help monitor overall health of the system, right? So whatever we have discussed in breakdown, okay, what to monitor, right? All those comes under the metrics, okay. The next pillar, it's logs, event records that they provide details context about what happened and when happened. So logs are really important. Traces, end-to-end tracking of results through a system, revealing bottlenecks and performance inefficiencies. By combining these three elements, team can detect issue, investigate root cause, and optimize system reliability, moving IT operations from reactive firefighting to proactive resilience. So observability goes beyond the monitoring and let us know the more insight about. And for that, it uses this three pillars: metrics, logs, and traces. So this is all about observability and how it works. Now this topic brings us to the end of part 1. Before we wrap up, if this tutorial helped you, please leave a thumbs up. If you have any questions or thoughts or any feedback you would like to provide, please drop them in comment. And if you would like to support us, please subscribe to our channel. So today we have covered the essentials. This concept lay the foundation for building effective monitoring system. In next video, we will explore the architecture of Prometheus and Grafana, dive into how they work under the hood. Stay tuned for day 8 part 2, where we take a deeper look into Prometheus and Grafana inner workings. Once again, thanks a lot for your love and support which you are providing us, which really means a lot to us. Thank you very much for that, and see you day 8 part 2 with more updates.